All right, let's get started. Welcome back to this series on Twitch. We really appreciate you hanging out with us this Sunday afternoon. Like I've been saying, it definitely looks like I'm going to be extremely busy with my real life job. So, yeah, I think our streaming schedule is going to be just Sundays from now on until we figure out, until things slow down and I get some breathing room. That's just the way projects are; they come in waves. So it'll eventually calm down, and then we'll have some time to get back at it. But for now, that's what we're just going to be doing. We're just going to be pretty much streaming on Sundays, just for the foreseeable future. So we're going to get back to finishing up at least the PCB layout on the fan tester. Get switched over. Boop. So we're going to try finishing up the layout, try to get this done. I won't get it ordered or anything and start building it until later because I want to get back to the actual project at hand, which is the stepper motor board. I have to build one. I have to build the next revision, get the testing done on it, and then we can get back to firmware. I'm hoping to get that done and built and ready to rock and roll before we, before long and get going, at least maybe for the next stream. That way we can get back to programming, getting the example code, and getting that test fixture moving. So that's what I'm shooting for. But for now, let's try to finish up this layout. So this isn't something that's just hanging over our heads. And then we can always get back to this while the other board is testing, while that test fixture is, driving and, it can be doing its thing. And then we can kind of finalize this and maybe start getting this one ordered and built up. Because we're getting close to the point that I'm pretty confident in the other test fixture. I'm really confident in it. The other board, I'm really confident in that design that we solve most of the problems, but the extended testing will solve that. We'll verify that. And hopefully we can get that pushed out and get it launched and up for sale. I'm really, really shooting for that. And then this board will also be up for sale too, this multi-fan tester. We'll get it out there for sale too. But for now, like I said, let's at least get the PCB layout done because, again, we could get back to this. And I think one of the things I'll also work on is actually capturing all the other documentation that I should have done for this, which is the PRD and all the other papers, all the other stuff. I should have really done that, but I didn't. So I'm not going to, cry over spilled milk. So we were tying up this part of the board. Again, these air wires that get solved once we actually plop our regions and tie them to the proper, basically the planes. But we'll do that once we get the board kind of snug together and the outline figured out how we're going to do. So it looks like this diode, this TVS diode, we need to get the ground tied in. And to do that, we want the region, and the 3 vias. Now we're going to come up here. I like doing it this way. Why keep redoing everything from scratch? We can just copy and paste. There we go. All right. Keep wanting to hit control. So we have quite a bit of room here. I don't want to be too close to this connector. Go to a 3D view or will it mess it up? Let's see here. All right. Because I don't have the part in. I don't have the parts library updated, which is something I'll try to work on. over time is update the library in here too to embed all the models. It'll just take time now that I figured out how to do it. All right. So yeah, I'm not too worried about the board shape right now, but we want enough room to be able to plug and disconnect the that. But we can probably pull the 3v3 power supply a little closer. And I think that's what this guy is. So, yep, 3v3. All right, let's not grab text for now. Let's grab this guy. All right, let's go to the 3v3 power supply, C11 and 12. I'm just going to drag the schematic off the screen to my other monitor to make it easier, so I don't have to keep flipping back and forth. 11 and 12. Keep these guys together. C13. Yeah, I think all these guys go together. So C13, L2. C14 and 15. All right. Yeah, these guys go all to go together. So let's see here. We could snug them a little closer to ESP32. All right, let's pull you down just a little bit more. I think as long as we have room to drop the connector in and plug it in and disconnect it, we should be okay. All right. Okay. Boost switch. All right. All right. So we have our ground, boost switch. That's our output. All right. Yep. And our input. All right. So let's not do that because we have our input caps right there. So okay. No, stop it. So that's our input caps right there. Pin 1 with feedback, that's fine. They can just get a via to the 3v3 plane. So we can push these guys just a little bit closer to the edge. Yeah. Let's go ahead and kind of fix this guy. All right. There we go. That's what we'll do. All right. So, how does it look like at 3? Let's not put it that close to the edge. Yeah, 4 is fine. There we go. Okay. Push you up a little bit. Okay. All right. Drop you in here. There we are. Okay. Get you moved. The another thing I'll be starting to work on is hold on, my train of thought keeps getting lost, is getting the stepper driver board into my main my main copy of Voto that I use for the Magic Forge for everything else. Basically, I'm going to splinter off, basically copy the project files as they are, version them to 3, and brand them for the Magic Forge. Getting our logo on them and everything. That'll be my own, on my own time. I'll video stream. I'll just get them branded, get the parts in, get the bill of materials all changed, all updated for the part numbers, any part numbering differences that might be schemed differently between my two systems. I should have just kept the same part numbers or insured, but that was my mistake. I didn't, but that's fine. Because I wanted to basically create the video series from scratch, and so it didn't work out exactly the way I probably could have had it work out. Okay, so that'll be that guy. But I'll start making preparations, and I'll probably start ordering parts for it too. I'm thinking about, for especially like 104 caps, 1K resistors, 10K resistors, the really common parts, any really common parts, just going and plunging down and just buying full reels, like 4,000 parts, just to have them, because I use them everywhere. So it's not just this project that they're used on, it's used on other projects, other things that I've done. So it'll work out in my benefit anyway. Let's see here. So let's get these guys out of the way, because this guy comes down. And I keep wanting to use the control key. Here's the boost. Get that text up here out of the way. The big inductor. And that is 45. Stop. 5. Let's see here. This guy. Come down here. It'll be part of that. I'll throw part of that polygon. This guy. All right. Let's see here. 12 and 5. 15. Nope. Ooh. Yep, that'll work. And then all right. That should be fine. I couldn't see if I can drop it down. Oh, 47. Yeah, let's go up to. Don't need that close. There we go. That's the boost cap. Then our nice big output caps. Stop. All right. So this is fine here. All right. Just beautiful. All right. So let's give those have. Let's go. 19. Go. Yeah, that's fine right there. That's fine. All right. Okay, that's the TVS diode. Geez, I wonder. Maybe the 5-volt supply, I can find a place to tuck it in right here. Okay, so 3v3 test point. Let's figure that out here. Oop. Figure that out here in a minute. Okay. All right. So let's get some regions going here. Ground. Again, I'm not too worried about it. I will straighten it out. And here I go again. Goal regions. Oh, yep. There I go. Forgetting to do. Oh, nope. Solid. No thermal release. I keep forgetting to do that. My bad. All right. So let's kind of bring you down here. Let's bring you down. Okay. Bring you out. So I can see what the progress looks like. Okay. So, go again, doing it. Let's copy the via. And paste some vias. Guy out a little bit more. And let's move you up here. So we can just, there we go. Beautiful. All right. Put that there so we can do this kind of similar over here. Ground. There we go. Oh, there we are. I don't see a similar problem with this guy like we had with the stepper. The driver. Right. Where the thermal characteristics of this, it was just drawing too much current this device will never source that much current to these to the fans and the LCD and the whole system. The system as a whole. So I don't foresee this having the same problem to where we have to make sure we really sink that heat out. Go. That one. Go. Drop our V's in. Right. Okay. There we go. Gives our nice little. Let's move that up as close as we can. A little snuggie. Let's just drop another V in for good luck and good measure. No reason not to. Okay. Now we got to plumb in our 12-volt line. We'll do a poly region here, and then off of here we'll probably just put a really heavy trace down to it. Again, we're not talking a lot of current. I like creating these poly regions for some solid base for our components to sit with. All right. We'll just definitely need to make some adjustments, but that's fine. Go. You there. We can probably pull you out here to that guy. Do the same here. That would be okay, I think. All right. See what it looks like. Just save it. All right. Any Vias, everything looks straight and clean. Let's pull that. All right. Probably drop this guy down just a little scoot, and this guy in just a little scoot. And that should be good. All right. Switch. Okay, net IC3SW. IC3SW. You don't need to pull that guy into the whole mess. Hello. But we will, because we can. Do a it looks like. All right. Get those guys straight first. Clean that up. That's fine. That's not going to hurt anything. All right. All right. Since that gets us the clearance anyway. All right. That looks beautiful. All right. Okay. All right. This we can just kind of. There we are. Okay, and now let's go to our 3v3. Plumbed in. 3. Boom. There we go. So you got some pretty good snapping on that. Little. Let's see how that looks. Good. Clean this up a little bit. No, you don't have 3v3. All right, a 3v3. Then what we will do is grab this guy. Because use the feedback. There we are. So now he's at the 3v3 for feedback. All right. Okay. We're looking good. We're looking good in the neighborhood. Oh. Doesn't like being overlapped in the courtyard, but I don't care. Let's clean you up for. Yeah, that's fine. I don't want that close together. That should be fine. Now let's move it a little further. Let's go back to 55. I want to make sure I have room to. There's room to clamp on to. There we go. Boom. All right. So that's the 3v3 power supply wired in. We could do the 5 volts. Did I have any test points of 5 volt? No. I mean, technically we don't even need test points for the 3.3 because it'll be over here. We could grab it over here. We just need a ground. Curiouser and curiouser. Because we'll have the voltages available. Well, not really. But this thing really isn't too much. It's supposed to be too much of a dev kit. It's a single purpose device. So, let's not worry about it. Those test points might go away anyway. So then this is the 5 volt power supply. How tempting to move. You know what? Let's get those guys out of the way for now. We may not even have them. Let's consider not having the 3v3 power test. Because what we can do, yeah, we can put the power supplies over here. Put this guy kind of up in here. Yeah, let's see what we can do. Let's see what we can do. Stop. Okay. We'll fix all this later. Grab its boost cap. Its inductor. Mainly these guys right here. There we go. Grab that. Bam. All right. Stop. Wrong button. Hello. Shift key, please. Thank you. Jeez Louise, guys. All right. So let's go here. 15.25. Okay. Let's push you up just a hair. Get you guys away from down here. Go up to... Yeah, you know what? That's fine. That'll work. 53. Stop. There we go. 19. Okay. Because we play our cards right. 10. Right. Let's try this. Let's grab that region. These vias. Kind of my biggest position as closely as possible. Bam. Now all we gotta do is just drop this guy. Yeah, go. Look at that. All right. So this guy we can grab. See, move out of the way for now. All right, and it's gonna be IC1 SW. And all right. Redraw all those, make sure. All right. Then this guy, we can start. All right. Here we go. All right. Let's grab this guy. 12.75. There we go. That might actually be perfect. Yeah. There we go. There we go. There we go. Now we're going to route this fella. All right, come on, little fella. There we go. Now let's get that to 5 volts. All right, make sure everything feels okay. Now we gotta get 5 volt off of that guy. So here we are going to go to bottom. Top. Grab off that guy. There we go. All right. Right. All right. These 4 millimeters. No. Stop. Go. There we are. Now we can fix that. All right. All right. Uh, all right. All right, should be close. We'll see how things look once we get that ground plane copied in there. Grab these guys. Go. All right. Actually, what I can do then is just grab this guy. Uh, right. There we are. Let's have that one. Oh, beautiful. Might as well just make a one big polygon. And we can do. Let's bring this guy down. There we go. The number. Let's go here. I'll bring it down a little bit more. All right. Okay. Oh, okay. It cuts. I start and Y. Oh, okay. Kind of figuring out where things are going to go here. I could drop that down just a little bit more. Let's see how that looks Yeah, I guess that would work. All right. This guy. All right. This guy. Okay. Boom. All right. That would actually work. Close. Let's just grab footprints now. There we go. It's a winner. Go 9. Okay. Looks like it'll free the edge over here. Might be able to go one more. Courtyard's overhanging. It's this guy right here. Woo! And the C's there. All right, so let's go 8.5. That should clear, make sure we clear the edge of the PCB. Yes. All right. Well, we can do that as 12 volts. Let's just go ahead and grab a zone. That's fine. That's fine. We'll all right. Zones. You know what? We can make that a little bit bigger. Right. All right. Let's see. What that looks like. We are. That's fine. And then we're going to need a D1-A. That would be good. I mean, kind of a waste of space. I mean, not terribly. Not completely a waste of space. I mean, I'm not really going for an uber compact layout anyway, but I also don't want to create a situation where the 12 volt, we have to do some weird kung fu to bring it over to this guy. I mean, it's going to be 12 volt raw for this anyway. I mean, it's fine. It's not going to be a super, extremely heavily populated board, but I guess that's fine. It'll work. We could do more and more to try to squeeze this into more of a dense PCB, but for its purpose, it's fine. It's slightly larger. I'm not terribly worried about wasted space per se on a board like this. I know some people out there would freak out, but we need to make sure we have enough room to tie everything together, have room for these guys so they're not squeezed too far together. Also let us have our test points and, things like this. We can have things better labeled, more properly labeled. Yeah, I could squeeze things together, try to get more of a dense board, but when there's no reason to, yeah, you pay a little bit more for the, the square inches, basically, the square millimeter, but sometimes it's worth it just to get a board that functions more along the lines of what you want. So we're going to grab another region. Grab it. Start from here. D1-A. Okay, we're going to come down here. Come over here. Fine, come up to here maybe. Over here. And again, we'll clean all this up. Fill it, see what it looks like. All right. That actually, nope. That actually worked out pretty well. It's kind of start cleaning you up a little bit. Try to get as much of this in as possible. All right, let's see what that looks like filled. All right. Okay. Oops. All right, we're going to bring this down. There's no reason to have it that far. There we go. B. All right. That looks fine. Because that extended thermal mask is going to make it hard enough to solder as it is. All right. The ground to get plugged in with the ground plane. So this is this. That way we can also pull off of this guy to go to the fans. It won't have to be as heavy of a trace. It'll just be a trace. Because it's going to be feeding the 5-volt supply of, one fan at a time. Basically. We're not talking a lot of current. So we could probably make it like a 0.508 millimeter trace or something like that. Just to make sure. But, it's not like it's going to be a heavy current. So... all right. Okay. We're making progress here. Let's start kind of trimming up the PCB size. I'll go back to all items. All right, 70. Where does that take us? Yeah, no, we need to be higher than that. 80 millimeters. 83. All right, 83. Yeah, just 2. That's fine to have a little bit of the connector hanging off the edge. That's fine. it'll make it easier to kind of design an enclosure for it as well. So I thought about, do I want to throw mounting holes on this? I don't know. We might be able to add some, or just design the enclosure. It's just kind of like snap locks and hold it together with brute force. I'm not sure yet. We might do like maybe M2.5, just a little smaller. We will see. So that's 82. All right. 82. 82. 0. Oh, no, that's 0. There we go. Okay. Our PCB is starting to all right. 0. Okay. So it's kind of all right. We'll start at 90. So let's go to 95. No. All right. So, okay, that pad is roughly 5 millimeters in. All right. 5 millimeters. So that pad is. Oh no, I was looking at the wrong one. I need the X value. X. Oh no, 5 millimeters. So it's going to be 87.5. 5. 87. Okay, so we're going to need to add 5 millimeters to that. I wonder if we can do the same thing. Oh, you can. Oh, I love it. 92.5. So let's get you selected. All right. Okay. 92.5. And then you're at 82 high. There we go. Now let's see. Boom. There we go. Now we're making some progress here. Yeah, mainly because these guys right here, I want you to be able to get into and access without fighting them. I want room for that. I want to make sure there's enough breathing room. Because there's nothing, to be honest, there's nothing more I hate than trying to get connections into connectors that are too close together. All right. Okay. So there's that. So we got plenty of room. So we could definitely add more test points since we have some test points there to add. So let me grab just footprints. Let's grab the usual 3. I don't know why it's putting those all the way over there. Text. Let's see about fixing that. Not like it matters. I was hiding. Oh yeah, show it. Okay, boop. Don't need to move that little tilde over. Stop. All right, so you'll be like right here. Go. Fiducials. All right. fiducial 3. Now, we will place you right here. Let's just go get you placed. Hello. Dear reference. Okay. Maybe we can snug you over towards that connector. Boop. All right. Let's see what you look like. Could put you over here on that side of the connector. Let's try that. 3. 2. Yeah. There we go. Perfect. On that side of the connector. As a general rule, you don't want to, if you can avoid it, you don't want to cover any of your fiducials with any component. It's just a general rule. It's not like super strict that you enforce it, depending on your exact needs of your PCB and your design. I have seen it where fiducials are snuck underneath components, like especially like through-hole components or larger components that, like say like a connector like this, or a ESP32 or something, or even a switch like this, just to save board space. I've seen that. Doesn't make it right. You're technically not supposed to. But again, sometimes you have to do what you have to do in order to get things to work. So, because we have all this room here, we can actually bring these guys. Let's... Stop. Just select one, you goofy mouse. Yeah, you know what? That's fine. That'll work. Put you up here. Grab you, put you up here. All right. Yeah, it should be close to a 3v3, but it's fine. I mean, we do have plenty of space. It's not like we couldn't. We don't have to populate them with the parts. I mean, we have room. That's just an FTDI header, so that's not a problem. So maybe we will add more test points as we go. Because we can put one for 5 volts up here. Again, it's not like it's for, you know, the heavy power supply testing. And in a way, we've already validated this power supply works pretty darn well. Woo, hello. Sent that thing to Timbuktu. 25. Because we're using the exact same pretty much circuit. The layout might be slightly different, but it's the exact same part components as the ESP32 unit. Or the stepper controller. I mean, yeah, this is an ESP32 based unit. So it's not like we have anything too overly complex, and we already know. 156. Perfect. Look at that. Who knows? We might add all right. Make sure they're coming. Nope. Oh, it's got the 28 with the egg. There we go. That's fine. There we go. Yeah, because we might add one for the 5 volts. We might just go ahead and do that. Because again, like I said, you don't have to populate them with the actual test points that we're using. Because the holes will still be pretty, you know, you'll still be able to like solder through wires or whatever. All right. So for programming, you know what? That doesn't really need to be up here at the edge. My goodness, there's going to be so much board space left. But I mean, that's perfectly fine. Again, there's some test points over here. We can always add a couple more. I'd rather have these guys closer to the ESP32. We can do them like right in here, even. Because it's not even a debug port. I'm not even going to throw a debug port in here. There's almost no reason to. You could technically use this as the debug port if you really, really wanted to. For how simple and how basic this project is, its specific purpose, it's almost not worth it. You know what? Yeah, if we throw another test point in here, this guy can kind of go up here. This guy kind of over here for a little more room. This guy can kind of sit here. In between them. Oh, look at that. Yes, yes, yes. All right, so 60. All right, 60 millimeters. $34. All right. There we go. Now, what we might do, let's do one, pardon me. One thing before we get too far, get the schematic back up. Let's change their designators. Why not? All right. And what we're going to do, update PCB from schematic. PCB close. There we go. Oh, no, let's get rid of the ones. I forgot to do that. I don't know why it wants to do that. Oh, I know. It wants to annotate them, but we don't need to annotate them. All right. Let's try that again. Tools, PCB. All right. No, I don't want to annotate. You. All right. Let's see here. Keep. Yeah, see, I don't want to put a number there. No pin 6 and symbol. Look into that. You know what? That's fine. Yeah, stop. We could drop them a little closer. That's fine. Let's go to... There we are. Okay. Now... All right, let's give that. Yeah. No. Right. No. Yeah, that's fine. 7.5. 34. Drop you in the middle. And boom. All right. All right. Let's go on the bottom. Copper layer. Nope, I need vias and zoom. There we go. Lazy approach. All right. Before we're done, let's go ahead. Nope. Top. Right. Print. Super big. They're just switches. Oh, there we go. Okay, drop it on the bottom. There you are. Got you on the bottom. Bam. And now we have vias, so it make it easier to kind of pull over here. Boot mode. Gonna grab you, bring you up. There we are. And ESP enables probably all the way down here. Yeah, sure. That's fine. Because what we're going to do, come on the bottom. Let's go and get this guy plumbed up while we're at it. No, fell. Right. Top. Boom. All right. Yeah, don't worry about the grounds. All right. Oh yeah, this ground tied in together here. Didn't even see that little fella. All right. Well, it's been an hour, and I think we'll call it quits here on this session. We're in a pretty decent spot. We'll finish plumbing up the ESP32 because we still have to get the tacks, get these guys in line. Yeah, a little bit of wasted board space, but we can use it to throw in, text, logo, because I'll definitely put our logo on here. More test points. We'll get these guys plumbed in once we figure out where all these guys are going to go. But this board's approaching the laid out stage, so it's making me happy. So with that, I'm going to call it a session, call it a day. Thank you for hanging out with me on this stream, and we will catch you on the next time.